All right, so we're talking about functions. 2.1 is about functions. We're supposed to finish this today. Hopefully we can. So functions. So a function is just a relationship. So there we have a relationship between people, right? We got John Doe. It's first name, last name, looks like, right? Katie Smith, Kia Hill, Marcia Brady, and Jan Brady. That's a first name, last name. You know, first name, last name is a function. It's a relation. All a function is a relationship between two things. So your first name and your last name, that's a relationship. It's a function. Is it a function? Yes. Let me give you the definition. A relation. So I guess not all relationships are functions, but a relation is a function. Does anybody know when's a relation a function? Nothing repeats in the x, exactly right. Every x goes to only one y. Let's say y. So every x goes to only one y. In other words, never one x going to two different y values. That's what you can't have. That's the big no-no. You never want one x value going to two. So you never want like one thing over here going to like it's John Doe or John Jones. We don't want that. We don't want one x value, even though of course that can happen in real life. You can have John Jones and John Doe, whatever. We would not call that a function. So you never. That would break the. It would be a relation, but it would be a relation that's not a function. So a relation is a function if every x only goes to one y, not two of them or more. So then, is this one okay? It is. What about the fact that both of these, and these are the x values and these are the y values? I probably should have said that. So what about the fact that you have both of these x values going to this one y value? That's okay, right? As long as you don't have one x going to two y's. 2x is going to 1y, that's fine. We don't care about that. That's still a function. We'd still call that relation a function. Okay, so, and then it comes down here and says, select a list that represents the elements in the domain. What does domain mean? X values. Yeah, domain means the x values. What's the y called? Range. The range. The range is all the way. So, just boom, there is the domain, here is the range. They're just going to ask you for that in those two parts that come after. Good so far? So we're going to get several different ways to look at a function. What is a function? It's a relationship between x's and y's, inputs and outputs. We'll call it different ways. Domain and range. It's a relationship. And it's a relationship where you never have one x going to two y's. You can have that kind of relationship, but it's not called a function if one x goes to two y's. It would not be a function. All right. These beginning ones. Okay. So there's a relationship between x's and y's, domain and range again. So the relation is the arrows. The arrows really are the relationship, aren't they? So is that relationship a function kind of relationship? No, the problem is this one x goes to two different y's, huh? So that one's a no. It's not a function. And then part 2 and part 3, they're just going to say, what's the domain, what's the range? Those are easy. So that one's not a function because we have one x going to two different y's. Different ways to represent a function. So I'm going to list them vertically. It might be easier. -2, -7, 8, -6, -9, -2, -2, -3. You see how these are the x's and these are the y's? It's the same thing as the last one. The arrows are just understood to be there. That makes sense? When they give me a point, -2, -7, you know it's x first, then y, huh? That's something you already know. So that's all. It's just a bunch of points. A point on a graph, a dot on a graph. Like if I go back to up 7, 4, 5, 6, 7. Oh, it's down 7, isn't it? Back to down 7. 7. So this dot right here, which is back to down 7. A dot on a graph has two numbers. Shows a connection between an x number and a y number. It's a relationship, isn't it? Dots on a graph are relationships between x and y values, aren't they? So what? Well, I'm going to write it vertically. Is this relationship a function kind of relationship?
No.
Yeah, it's not. Why? It breaks the rule. It has one x going to two y's. What x value is that?
Negative.
Yeah, -2. That same x goes to -7 and -3, doesn't it? Hey, let's put it on the graph. I already did -2, -7. Let's put -2, -3 on the graph. This will be right here, isn't it? Back 2, down 3, back 2, down 3. This is back 2, down 7. What do you notice about those two dots?
It's not past the vertical line.
It fails the vertical line test. Remember the vertical line test from your algebra days? You never want a vertical line hitting two dots. Well, here's why. Because when a vertical line hits two dots, if we had some kind of graph or something like that, and we had a vertical line hitting those two dots, that would mean same x value, different y values, right? That's what it means to have two dots on a perfectly vertical line. Same x value going to two different y values. So the vertical line test is another way of saying you don't want one x value going to two different y values. That's what that means, huh? Yeah.
So would that mean that an equation for a parabola is not a function?
This is not a normal parabola. A normal parabola would be up or down. Those are functions. This is a sideways parabola. This would be a y would be squared instead of x. So those are not functions, yes. That's right. Okay, so that one's not a function. Well, different ways to see this. Now, they're going to give me, they're not going to give me lists of x's and y's. They're just going to give me an equation. How do I know from an equation? Well, you've got to kind of think about what x's and y's would be on this graph. Yeah, how about you? Do you guys know the graph of x cubed? What does the graph of x cubed look like? Yeah, do you know it? I'm impressed. You guys know it? I always call it the snake. Yeah, x cubed is like that. And the 2 is just going to make it go up and down, up like this way, up and down faster. Same thing, basically. So there's what it looks like. There's the x cubed graph. So if you know the graph, then you can ask yourself, does that graph break the vertical line test? Remember the vertical line test from algebra? If any, let me write it down. If any, this is the vertical line test. If any vertical line hits 2 points or more, then it's not a function. Oops. That's the rule. So if any vertical line hits 2 points or more, it's not a function, because that means one x going to two different y's. That's what a vertical line hitting 2 points would mean, as we just saw. So let me ask you, vertical line, vertical line, vertical line, vertical line. No, they're only hitting 1 point, huh? All those vertical lines are only hitting 1 point. So this one is yes, it's a function. Does that make sense?
Yeah.
On that? So that one's okay. That one's a keeper. How did we figure it out? Well, we knew the graph. Did we know the graph? What if they give us a bunch of equations where you don't know the graph? How are you going to decide if it's a function or not? We better come up with a nice little handy-dandy rule. Let's think about it for a second. What kinds of equations? You know what the problem would be, right? We don't want the thing doing like I showed you a minute ago, going sideways like that. If you have the thing going sideways like that, that's not going to be a function. Well, I might not be helpful to bring that up. Let me just say this. What could I do with the equation that would make one x correspond to two different y's? Anything I could do with the equation that would cause that to happen, it's going to be a problem.
Maybe if like it was if you square rooted it and oh no I mean if you squared it, because negative times negative.
Yeah, you're thinking right. Let's talk about squares. Yeah, it has to do with squares. So let me slow down for just a minute and reason with you. So remember the rule. Something's a function if, let's see, you don't want this. You want not 1x going to 2y's, not failing the vertical line test, right? Something's a function if every x goes to only one y, right? Now think about, let me just back up for a minute and think with you about this equation. If I was to make a table, just forget about the picture for a minute. Let's just think about x, y's. If I was to make an x, y table for that equation, let's just start with like 0 and 1. And if I was to plug something, if I was to plug in 0, what would I get? 2 times 0 cubed is 0. Okay, big deal. Plug in 1. 2 times 1 cubed, what's that going to be?
2.
It's going to be 2. 2 times 1, 2, right? If I was to plug in 2, what am I going to get? Well, whatever that is, some number 16. And etc. Is there any way, think with me guys for a minute, and gals, is there any way, if I were going to plug in a number here, that I could get like 2 answers for the y? Is there any way to take 2x cubed, plug in the x, cube it, multiply by 2, and then have like 2 different options for the answer?
No.
Like, no way. No way. Every x you plug in is going to lead to only one answer. So this thing's going to be a function. That's why it's yes, it's a function. Because there's no way you're going to plug in one x and get 2 different y's. Now, if I was you, I'd probably be thinking, well, how could that ever happen? What kind of weird equation could you ever plug in an x and work it out, and all of a sudden there's 2 answers? Where does the second one come from? What do you mean there can be 2 answers? There actually can. It's like what he was saying. If the y was squared, let me show you for instance. Yeah, what if I gave you like y squared is x? Let's think about that for a minute. Do you see what that would do? So if I do the x, y thing, see I plugged in x as something like 4 for x. What could y be? What squared equals 4? 2 or negative 2. Right? See, there's 2 options for y to make it true. Do you see that? This one would not be a function. So you see the deal? If y is squared. That's it. That's when you got 2 options on the y. If y is squared, then you can do positive or negative to make it work. Because it's squared, it buries the sign. Do you see that? Does that make sense? So let me write out, having observed that, and it's not just squared, what else buries the sign? Any even power. You with me? Any even power on the y will bury the sign. Right? What if this was 4th power? Would that be a problem? Absolutely. Because I could put in some kind of number. Like if I said, hey, this is I want x to be 16. So what to the 4th power is 16? 2 or negative 2. 2 times 2 is 4 times 2 is 8 times 2 is 16, right? 2 to the 4th or negative 2. Right? You with me? Did y'all see that? 2 answers again. You see, whenever you have an even power on the y, you're going to have positive or negative options for the y that both equal the same x in the end. They both become positive in the end. Whereas if this was odd, you would think, really, is it even that's the problem? It is. If that was 3rd power, odd, we would not have that problem. Why not? Yeah, let's work it out. Well, like what if I made this 8? What if I said I want x to be 8, so what to the 3rd power, what multiplied by itself 3 times is 8? 2. 2 times 2 times 2, right? 2 times 2 is 4 times 2 is 8. So you think, 2, yeah, but or negative 2. No, not or negative 2. Negative 2 to the 3rd power would 3 negative 2s? That's negative 8, not positive 8. So yeah, but okay, I bet if he put negative, yeah, if I put negative 8, he would go with negative 2, but you never have the same x going with 2 y's. Those are different x's going with different y's. We're fine with that. We just don't want one x going to 2 y's. Do you see the issue then? It's even powers on the y that cause the problem, isn't it? Right? All right. So having said all that, let's summarize the story. So for equations, there's a simple story. If you, well, actually, I just realized there's one more part to the story. So anything that buries a sign on the y is a problem, right? Other than even powers, do you know what else can bury signs? Absolute values. So if there's an absolute value on the y, or y to some even power, then it's not a function. Otherwise, if it doesn't have either one of those things going on, it is a function. That's the simple rule. You guys get a 3x5 card for the exam. When's our exam? We got a couple weeks still. 6th. So week after next on Wednesday. It's 2-day, part of 1 day, half of 1 day, all the next. 6th, 7th, week after next. Anyway, on that day, you get a 3x5 card, write anything you want on both sides. I'd put that on there for sure. That'd be a very valuable thing to put on your 3x5 card. Absolute value of y or y to an even power, not a function. Otherwise, that's an it there. It is a function. Is that good? So these will be a snap. These will be a snap now that we thought through all that. Get that down, kind of clear off that. It'll be on YouTube later. If you, I showed you how to go to YouTube, didn't I?
Yeah.
Good. All right, so we got y equals 4 over x plus 3. They're saying, hey, is it a function? Yes or no? Yes. You just look and go, does it have absolute values? No. Does it have y to an even power? No. Then it's good. Right? So this one's yes. Done. That quick. Don't need to plug anything in, mess with anything. All we're doing is we're just inspecting it. We're just looking for absolute values or even powers on the y. If you got either one of those, it's not going to be a function. If you don't, it's good to go. That quick. That's a problem too. Yeah, because plus or minus is two options, right? So, all right, y is plus or minus. So that's not a function. Yeah, because absolute value squared, same thing as plus or minus. Yeah, so let me write the whole story. The real whole story now. It's not a function if you have y to the even, you have absolute value y, or plus or minus on the y. Any of those would give you two options on the y for the same x, and we don't want that. So this one's not a function. It literally has a plus or minus sitting there on that. Now you might think, well, the quadratic formula is not a function. No, that one's okay because that's x equals plus or minus. That's not y equals, right? We're saying y can't equal plus or minus. All right, so that's no good. That one's not a function. So here's number 10. X minus 1 is y squared. Is it a function or not?
No.
No. Even. Even power. Not a function. You'd like to see a lot of those on the exam, right?
Yes.
There'll be at least one. Probably just one. Not a function. All right. Even powers, absolute value, or plus or minus. Not a function. Otherwise, so y equals 4x squared plus 2x minus 4. All right, so is this one a function?
Yep.
Yeah. You might say, yeah, but what about the even power? It's okay. There's no even on y, so it's a function. Well, I should say it is a function. It is a function. There's only even powers on x. Right, you with me? See, so again, any x value you plugged in would only produce one y, right? Pick any x number you want. Plug in -7 or whatever, you know. Plug that in. Whatever, you're going to work out some number. It's only going to be one answer for y. There's not going to be two y options, are there? So that one's good. He's a function. He's not a problem. It's only when the even power's on the y, or there's absolute values on the y, or y, the plus or minus doesn't have to be on the y, though. The y just equals the plus or minus. Did I say that correctly back here? Yeah, I should say, or y equals plus or minus. It doesn't matter. It doesn't matter where the plus or minus is, because that's giving two options to everybody, basically, right? So it doesn't matter where the plus or minus is. The even power is on the y. The absolute values have to be on the y. The plus or minus can be anywhere, and it's a problem. All right. Okay, so we've got f of x is 4x squared plus 3x plus 3. And we're doing f of minus 3. So we're supposed to plug minus 3 in there for x. So you guys comfortable with function stuff, right? It just means plug in that -3 everywhere you've got x. I just want you to practice working that out. Let's do that. And then just work it out. What is that? Use a calculator or whatever. 4 times 9 plus negative 9 is 336. Is it 30?
Yeah.
There it is, 30. Is that good for that one? Let's just plug it in, making sure you're good with functions. Let's see what the other. All right, everybody get that down okay? So here was the last one. I just plugged in -3, worked out to be 30. All right, so now in part B, they're saying, let's figure out, again, let me write f of x up here. The original function f of x is 4x squared plus 3x plus 3. What's f of negative x? Okay, so this just means we're plugging negative x in for the x in the function, right? Remember when you plug into a function, you put parentheses around it when you plug it in? So let's do that. Is that good? And what do we get here? 4x squared minus 3x plus 3. Everybody good with that, right? The positive 3 times negative x made the negative 3, whereas this first negative sign was squared, so it went away. We good there? All right, so that's part B. Let's come over here and do part C.
That negative threw me off.
So now the difference between B and C, on B we have the negative inside, on C we have the negative in the front. So they're making sure you understand the difference between those two. So when the negative is in the front, that means it's going to hit the whole function, not just be plugged in for x. Right? So in part C, the negative is in the front of the entire function. So that means it's like negative and then parentheses. Why parentheses? Well, that way I indicate that it's affecting the whole function. Let me hold on for a minute. Are you getting what I'm saying? Are you, as they say in the South, are you smelling what I'm stepping in? That's my favorite Southern saying. I like that. It gets the feeling, doesn't it? Are you tracking with me close enough to smelling what I'm stepping? Do you get that? What I'm saying there? Why on part C? Why would it be wrong to write it like that? I'm saying that's wrong. Don't write that. That's not true. Why? Why is that not true? They said negative f of x, and I put a negative sign, and I put f of x. What's the problem?
You didn't distribute it to the other two numbers.
Yeah, well, right. So you're saying you didn't put the minus to there and there. Well, why do I have to? Who says I have to?
Because it's in front of the f and not the x.
Yeah, because when it's in front of the f, we know, everybody knows, that means negate all of f, not just part of f. That means the negative of all of f, right? Whereas part B meant plug in negative just for the x, just where the x's were. But this means negative all of f. Well, how do you negate all of f? That's why I bring the parentheses in. Or you can just run the negative through right away. You can skip the parentheses step if you want to. As long as you eventually take the negative to everybody, it's all good. You don't have to do the parentheses step. If you want to just go right to that. So that makes sense. Yeah, that's actually true. That's not just my opinion or somebody's. That's what this says. Negate all of f. So now I've negated all of f. So again, you can skip the parentheses if you want. Just run it through. Question, comment?
Which one will the computer want?
Oh, no, this is the final answer. You got to get here eventually. I'm saying you don't have to, you can skip that step if you want. But one way or the other, you got to get to here. That's what the computer wants. And then part D, let's go. If you guys got that down, I'm going to go to part D. So part D then is even a little more complex. So part D here, again, f of x, the original function, is 4x squared plus 3x plus 3. They want us to say, okay, what's f of x plus h? Well, what do we do? Same thing, plug that in for x. So like that. Good to there so far. So I just plugged in parentheses x plus h everywhere we've got x. So right there and right there. And now we just got to work all that out. We just got to FOIL and gather like terms and all that kind of stuff. So, excuse me. And bring it over here. Leave that 4 sit in the front. I would just leave it sit there. And do x plus h, like that. And this 3 will distribute. So notice I'm gonna do the parentheses first. I'm gonna write 2 of these x plus h's, right? That's what the 2 power means. And I'm gonna FOIL these first and leave the 4 just sitting in the front for now. So I'm gonna FOIL here, boom, 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 boom. Remember all this kind of stuff? X squared plus xh plus xh plus h squared. All good to there. Oops, getting a little scribbly. And then the rest of the stuff. Good so far. And then I should gather, these two are like terms, aren't they? XH and XH is 2XH. Remember all those rules from algebra? Right here I'm going to add 1XH and 1XH to get 2XH. Why don't they make 2x squared h squared? Because they're not multiplied, right? Remember, it's when you multiply letters that the powers change. We're just adding there, so you just add the numbers in the front, right? Right here. So it'd be x squared plus 2xh plus h squared plus 3x plus 3h plus 3. Good so far. And then that 4 distributes. Boom, boom, boom. I'm running out of room. I'm going to have to bring it up here now. So bring it up here. So what do I get? 4x squared plus 8xh plus 4h squared plus 3x plus 3h plus 3. We're almost there. I think we are there.
Yeah.
There's nothing that combines, huh? So that's just it. No, there's no more like terms to combine. So that's just it right there. Big, big mess. Is that good? Questions I can answer on that? Especially right here was probably the trickiest part, you know, foiling out the x plus h and like terms and then multiplying. All is well? Question, yeah.
When you put it in the computer, should it be like in order by like the top?
Yeah, I don't think it cares what order. Yeah, it's fine. Any order's fine. Yeah, let's do part D. Let's just skip all the easy ones. You could do all those. They'd be easy for you. Let's go right to part D. So the function f of x is 3x over x squared plus 6. And they're asking us to find f of x plus h. So go ahead, put in x plus h for x in those two spots. So what do we get? We distribute up there, 3x plus 3h. Down below, it's going to be x plus h plus 6. And then distribute x squared, oops. X squared plus xh plus xh plus h squared plus 6. You okay with all that so far? Just foiling all that out. like that. And then just same thing, going to gather like terms down here, right? XH and XH is 2XH. So we're going to get, so in fact, how about I just save time and effort? Just say, combine these two, 2XH. So there's the answer on that one.
Oh, really? I was going that route, but then I decided to just cross things out.
We good? Questions I can answer on that one?
I mean, that makes sense.
I just realized one important thing would be to, I think part C is important. Let's take a look at part C really quick. They want me to take negative f of x, and you know what that means. That means a negative in the front, not plugged in, but in the front. How do you do that? Because the function, the f of x is 3x over x squared plus 6, right? Am I racing ahead? Are we all good with this?
Yeah.
We good? Questions? Okay. So here's f now. I'm supposed to put a negative sign in the front, and I could do it. I could just stick it right there. Here, let me just change the color for emphasis. So I could put it right there. Just stick it in the front, and that's okay. That's right. That's true. But what are the other options? Are you comfortable with negative? This will become important pretty soon. Even on this one, maybe if I give you a multiple choice question here, I'm not sure which way I'll go. But you could. Would it be right? Let me ask you. Would it be right to put that negative on the top only?
Yeah.
Yeah, that's also okay. Do you realize that? Negative in the front, or negative in the top only, or you can put the negative in the bottom only. Now, when it goes to the bottom, it'll hit everybody. Negative x squared minus 6. That's okay also. Do you realize that? That's really important. So no, I think it's confusing with all the x's and stuff. Let me just write with a normal fraction. If you have a negative in the top, or you have a negative in the bottom, that's the same as a negative. There's no room there. That's the same as a negative in the front. So if you have a negative in the front of a fraction, that's the same as the negative in the top or a negative in the bottom only. Are you aware of that? That's really important as we deal with fractions. When you have a negative on the fraction, you can put it in the top only or the bottom only. It's correct. It's fine either way. You can't put it on both. Why can't you put it on both? Yeah, two negatives would be positive, huh? So all the time they'll be doing that in more complex stuff we're doing, and certainly in calculus. They'll put it in the top, put it in the bottom, leave it in the front. It's all the same, right? So I left it in the front here, left it in the front, put it in the top. Here in the bottom, when it goes to the bottom, if there's more than one thing in the top or the bottom, when it goes there, it'll hit them all, right? So when it went to the bottom here, it hit them all, didn't it? Good with all those facts? Those are all right. Math Excel knows it. It'll take any of those three. It knows they're all right. Okay. So we have f of x is minus 7x plus 7. And it asks us, what's the domain of that function? So how do you do domain? What do they want us to do for domain? Well, let me give you two different things to do. Number one, if there's a denominator, you say denominator, you cannot be 0, and you solve. Did we talk about that? I think we did, didn't we? No? Oh, thinking of something else. So if you have a denominator, which we don't on this problem, but we will in the next problem. So if you do, you never let the denominator be 0. That's a big no-no in math. You aware of that, right? You can't, for example, if you took 3 divided by 0, that's just an error on your calculator. It's undefined. You aware of that? 0 on the top is fine. That's just 0, huh? But 0 on the bottom is, it's because it makes no sense. There's nothing in the real world. There's no connection in the real world to having 0 in the bottom of a fraction. It's impossible, right? I'm going to run out of time, but it's probably worth it for just a minute. I'm not going to make it through 20 questions anyway in 4 minutes. All right. So is math real? I think it's important to talk about this right here. Is math real? Yeah. Math itself. I mean, just math, straight math.
Yeah. Yes.
Really? What if I said, hey, I saw 3. I was on the way to class this morning, and there it was. I'm right next to the eclipse. I saw 3. Right? You'd think, what do you mean, Mr. Heron, you saw 3? You saw 3 people or 3 cars or some kind of 3 suns or moons in the eagle. Wait, 3 what? No, not 3 objects, people, cars, anything, just 3. You'd go, what do you mean? You saw like the number 3 written somewhere? Is that what you mean? What do you mean? No, I didn't see the number 3 written anywhere. I didn't see 3 objects of any kind. I just saw 3. I'm ready for the padded room, right? You can't see math. Why? Because math isn't real all by itself, is it? You can't taste, touch, or smell math all by itself. It's just made up. We just made it up. It's in your head. It's in my head. It's just in your head. It's not in the real world. Well, then, what are we doing here? Class is over, right? Math. I was the dean. Don't tell the dean I told you this secret. I'm just joking around. I mean, hopefully you agree with that. Math is not real, but we made it up. That's true. We made it up. We made it up to describe things that are real, right? Math itself is not real, but we use it to describe things that are real. If I saw 3 cars in a head-on collision in McKinley and Blackstone this morning, I could come to class and say there were 3 cars in this accident. You have the concept of 3-ness in your head. I've got the concept of 3-ness in my head. We can communicate about things that are in the real world, right? Math is made up to do real-life purposes like that. Well, that gets back to the 0 thing. You can't have 0 in the bottom of. I mean, when we say you cannot, we mean there's no connection to the real world. There's nothing you could do in the real world that would would make sense out of this. This is not something you can do in the real world. Now, you might say, yeah, well, you can just, right? Because think about what a fraction means. If I say I ate 1/3 of the pie last night, you know what that means. There was 1 pie, and it was cut into 3 pieces, right? So what would it mean if I said 3/0? How do you cut into 0 pieces? You might think, don't cut it. No, if you don't cut it, it's 1 piece. If you don't touch it with a knife, it's not 0 pieces. It's 1 piece. How do you cut it into 0 pieces? You cannot do that. Not in the real universe in which we live, right? The universe has not been designed that way. You can't cut something into 0 pieces. So that's just baloney. That's why we always restrict it. We always say, don't let the math do. Now, math doesn't know that because math's not real. Math will go there, but you don't go with it. When math goes there to get a 0 on the bottom, you just say, no math. There's no connection to the real world. That's why we say undefined. Your calculator gives you an error. So we look for functions that have denominators, and if they have a denominator, we say denominator, we cannot be 0. Question, comment?
And cut something into nothingness. If you drop an atomic bomb on that cake, it would the atoms would break, and then that would turn into nothing.
Well, we don't need to get too philosophical, but one might argue that atoms, wherever they are still something. But anyway, hold on. I want to use these 30 seconds. All your money's worth. Hold on. All right. Number 2, if you have the inside of a square root, you say inside. You have to be greater than or equal to 0. On this question, so those are the 2 things you look for. On this question, do we have a denominator? No? We got no denominator. Do we have any square roots? No. Then we got no problems. The domain on this one is everything. How do you say everything in interval notation?
Negative infinity to infinity.
Positive infinity. Yeah. All right, we're going to stop there. We did not